Welcome back to another one of my learning derivatives videos. This video is focusing on deriving inverse trig functions. We're going to be using the product rule and Lagrange's notation, which looks like this. So you have a function multiplied by a function, another function, and the derivative of this function will be derivative of the first multiplied by the second plus the first multiplied by the derivative of the second. Okay. So, our first example, I've already written up most of all the colors because it takes too much time, but we have the inverse of secant of x multiplied by x squared. Okay, forget all this for a minute. So this is the same as arc secant of x, they're just written differently if you come across the arc sec x. But anyway, so we have a function multiplied by a function. That'd be signified with, we have to pick one of these to be fx and one of these to be gx if we're going to use the product rule, because the product rule requires a function times a function. That's better. And the derivative is the f dash multiplied by g plus f multiplied by g dash. So first we've got to pick one of these to be f and one of these to be g. So we'll just pick them above. We'll pick fx to be secant of x, inverse secant of x, and we'll pick gx to be x squared. Okay, now we're going to find the derivatives. So the derivative of the inverse of secant of x is 1 over x square root of x squared minus 1, and the derivative of x squared is just 2x. Okay, so now we have this, we can fill out this formula. Okay, so we have the derivative of h equals derivative of fx, 1 over x square root of x squared minus 1, multiplied by gx, which is x squared, plus fx, inverse secant of x, multiplied by the derivative of gx, which is 2x. Okay, now we're going to do simplifying. So we've got an x here and an x here. Take one off the top, get rid of the one on the bottom. So that'll look like x over the square root of x squared minus 1, plus, we'll just bring the 2x out the front, followed by the inverse of secant x. And that there is our derivative of inverse of secant x multiplied by x squared. Okay, now for our second example, got that written up. We have 7 to the power of x multiplied by the inverse of tan x. So we have a function multiplied by a function. We'll call this one fx and we'll call this one gx. This is what we need in order to find the derivative of fx multiplied by gx plus fx multiplied by the derivative of gx. I've got them written down here. We just need to fill them in. So 7x is fx, 7 to the x, and inverse of tan x is gx. Okay, so let's find the derivative of 7 to the power of x, which is ln 7 multiplied by 7 to the power of x, and the derivative of inverse of tangent x is 1 over 1 plus x squared. Okay, now we have all this, we can go ahead and fill out the answer. So we have our h dash x equals, okay, derivative of fx, that is ln of 7 multiplied by 7 to the x multiplied by gx, which is the inverse of tan x plus fx, which is just 7 to the x, multiplied by derivative of gx, which is 1 over 1 plus x squared. Okay, now for the simplifying. So we have a 7x multiplied on either side of the addition sign. So we're going to factor that out to the front. And what we're left with is ln 7 multiplied by tan, or inverse, tan of x plus 1 over 1 plus x squared. And that there is our derivative for 7 to the power of x multiplied by the inverse tangent of x. Thanks for watching this video. I hope you learned something and have a good day.